With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. So the question is, figure shows plot of PV upon T versus P, where P is the pressure, V is the volume, and T is the temperature for 1 into 10 the power minus 3 kilogram of oxygen gas at two different temperature, and these temperatures are T1 and T2. So in the first part they are asking what does the dotted plot signifies. As you can see, there is a dotted line, and in the question we have to tell what does this dotted plot signifying. And second question is which is true, T1 is greater than T2 or T2 is greater than T1. And in the third question, what is the value of PV upon T where the curves meet on y-axis. Okay, so in first part they are asking about the dotted graph or the dotted curve. As you can see, this dotted curve is showing that the value of PV upon T is constant. Okay, in this dotted curve, the value of PV upon T is constant, and PV upon T is constant for the ideal gas behavior. That means this dotted graph is signifies the ideal behavior of the gas, or I can say that this represent the ideal gas, represent the ideal gas, because we know that ideal gas equation is given by PV equals to nRT, where n is number of moles which are constant for oxygen and R is universal gas constant which is also constant. That means PV upon T equals to constant for ideal gas, and this dotted lines is also saying that PV upon T is constant. Okay, value of P upon T is same for all the values of P, as you can see. That means this signifies or represent the ideal gas. Okay, so this is the answer of first part. Now in the second part they are asking what is true, T1 is greater than T2 or T2 is greater than T1. Now as you can see, this is graph. Suppose this is the first graph which is having the temperature T1, and this is the second graph which is having the temperature T2. Now as you can see that curve of gas at T1 is closer to this dotted graph which is showing the ideal gas behavior than T2. This T1 curve of gas at T1 is closer to curve of gas at T2. That means I can write that curve of gas at T1 is closer than curve of gas as T2, curve of gas at T2. Now we know one thing, that real gas approaches the behavior of ideal gas when temperature is increased. Real gas showing the behavior of ideal gas when temperature is increased. Real gas showing ideal gas behavior only when temperature is increased. Ideal gas behavior when temperature is increased, and temperature is increased. That means this curve is near to ideal gas behavior. That means this curve is showing more ideal gas behavior. That means temperature of this curve is greater than temperature of this curve, because this curve is showing more ideal behavior, more ideal gas behavior. That means temperature T1 is greater than temperature T2, because curve of gas at T1 is closer to this dotted graph, which dotted graph is showing the ideal gas behavior. Okay, so for ideal gas behavior, real gas must have a high temperature. Okay, so T1 is greater than T2. So this is the answer of second part. Now in the third part they are asking about the value of PV upon T. Now we know that PV upon T, basically from ideal gas equation we know PV equals to nRT. So PV upon T is basically equal to nR. N is number of mole and R is universal gas constant. Number of moles is given by mass upon molar mass. Now mass is given as 1 into 10 the power minus 3 kilogram, and molar mass is 32 into 10 the power minus 3 kilogram. So putting the values, PV upon T, that is equals to, because for oxygen molar mass is 32. Okay, so it is the value of N is 1 into 10 the power minus 3 upon 32 into 10 the power minus 3 into value of R is 8.314. 8.314. Simplifying this, we will have the value of PV upon T, that is coming out to be 0.26 joule per Kelvin. This is the value of PV upon T for oxygen gas, 0.26 joule per Kelvin. Okay, because in the question they are saying where the curves meet on the y-axis. As you can see on y-axis, these two curves are meet on x-axis as well, and y-axis too. On y-axis they meet at this point, that means they are showing the ideal gas behavior. That's why we are using the equation PV equals to nRT, because on y-axis they are behaving like an ideal gas, because they are meeting at this point, and at this point gas is behaving like an ideal gas. So we are using the equation PV equals to nRT. Okay, thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.